Okay guys, welcome back for part 2. We are going to start looking at how these bitwise operators work. This is the AND operator. Now remember in the last lecture we talked about our AND gate. Over here in computer components. Right here. So to get a 1 out of an AND gate you have to have 2 1s. So let's go to the try it. How does a 5 and a 3 give you a 1? What happens if we change this 5 to, let's just say, a 7? We get a 3. How is this possible? What kind of math are they doing to make this happen? Check this out. Check this out. Get ready for this. Make sure you're ready for this. I'll go down here so everything else is off the screen. So that 7 in binary is a 1, 1, 1, 1. You got your 1's place, your 2's place, your 4's place. I just did a 16, I'm sorry. So 1 plus 2 plus 4. 1 plus 2 plus 4 gives you a 7. I know it's not in this table, but a 3 plus a 4 would be a 7. Okay, so what was the other number in W3 schools? It was a 3. Okay, so let's go back over here. Now a 3 in binary is 0, 0, 1, 1. Okay, now here is where it gets weird. If you take... Here's where the AND gate comes in. Here's where the AND. You need a 1 and a 1 to get a 1. So right here you have a 0 and a 0. So you get a 0. You have a 0 and a 1. That's not a 1 and a 1, so you still get a 0. Now, here you have a 1 and a 1. You get your 1. Right here, you have a 1 and a 1. Again, you get your 1. What's 0, 0, 1, 1 in binary? Here's the 1's place. Here's the 2's place. That equals, oops, 3. Crazy, isn't it? Let's try one more because this is confusing. Let's change this 7 to a... Would a 5 make any difference? That'd be a 0, 1, 0, 1. It should. It should lower the number. I'm trying to do it in my head. I think we're going to get a 1 or a 4. Let's see. Well, here, let's see if we can do... Oh, it was a 1. Okay, so a 5 is 0, 1, 0, 1. So we got a dash mark in our 4's place and in our 1's place, which gives us a 5. The 3 is 0, 0, 1, 1. With the AND operator, and in the AND gate, you have to have 2 1's to get a 1. So we have a 0 in that category. There's a 0 and a 1, gives us a 1. A 1 and a 0 gives us a 0. A 1 and a 1 gives us a 1. So a 5 and a 3 with the AND operator gives us a value of 1. Now let's go ahead and try the OR operator. Now remember the OR gate, let me go over that one more quick time. Look at your chart. Either of the values now can be a 1 to get a 1 out. Here's your OR operator. Let's try it. So a 5 and a 3 now gives you a 7. Let's just change this one. Instead of doing it all over, we'll just change this. There's a binary 5. So now we have 0, 0 is a 0. Oh, there's a 1 in this category. If either of them have a 1, you get a 1. This one has a 1, and this one has 2 1's. So that's 1 plus 2 plus 4, which gives us 7. Now let's change this to 10 and see if we can predict it. So a binary 10 would be 8. That's an 8's place. That's the 4's place. That's the 2's place. 8 plus 2 is 10. And then a 3 is... So what do you think we're going to come up with? This is the OR gate, so we have a 1 here, a 0 here, a 1 here, and a 1 here. So 10 and 3 on this one would end up being 1 plus 2 is 3, plus 8 is 11. Let's see if we got it right. That's not an 11. And this is actually really cool, because this is this kind of gives you an idea of how your programming language is actually interacting with the CPU. This is actually the first time I have ever seen the link between software and the hardware. I knew that the hardware was zeros and ones, and I knew that I know how to use certain types of software, but I've never seen the actual connection between the two. This is the first time for me too, so this is pretty interesting. Let me see what comes next. You know what? Let that digest. That lecture, I think, went pretty well. I hope it makes sense to you. Let me stop it right there, and then we'll go over the last three.